Good afternoon, everyone. I'm Nancy Melenda, VP of Communications for the Aluminum Extruders Council. Welcome to our webinar, Update and Recommendations, plus Field Repair Methods, Cleaning and Maintenance of Curtainwall and Facade, presented by Chris Incorvaia. Before we get started, I have some housekeeping announcements. All computer, audio, and telephone lines are muted, so if you have a question during the webinar, please select Questions or Chat from the toolbar. Type your question in the dialog box and our presenter will address your question at the end of the presentation. For those of you who are not familiar with us, the Aluminum Extruders Council is a trade association representing more than 75% of North American aluminum extrusion production. AEC is dedicated to providing information and education about aluminum extrusion and its processes to architects, designers, engineers, and others. AEC is also focused on enhancing the ability of its members to meet evolving market demands through knowledge sharing and best practices. For more information, visit our website at aec.org. We will send an evaluation survey following this webinar. Please complete the survey. We value your opinion and count on your feedback to bring you the content and topics you have come to expect from AEC. Now let me introduce our speaker for today. Chris Incorvaia, National Manager of Facade Restoration for Stuart Dean, has over 15 years of expertise in architectural facade and curtain wall restoration. He has successfully managed through to completion over 300 high-performance coating projects. Chris is responsible for the promotion, sales, and development of national and international facade substrate restoration services to new and existing clients. He is subject expert in facade restoration, pre-installation finishes, and high-performance coatings. Chris's primary mission is to develop building envelope solutions in order to improve and/or enhance an asset's value and appearance, and protect and/or preserve restored facade surfaces and extend their surface life. In his presentation today, Chris will be delivering a management overview for restoring metal building facades, along with the use of VOC-compliant replacement products for poorly performing or aged coatings. Welcome, Chris.
Thank you for having me. I greatly appreciate it. Good morning, good afternoon, depending on where you're at. A couple other items I'd like to add sort of to the credential or background of our facade team. All of us are NACE certified coating inspectors. We also sit on the committee with AMA for the 2605 standard and reviewing that standard, making recommendations and changes to it on an annual basis. We're also actively involved with SSPC, the Society of Protective Coatings, and we were integral to the committee that just recently completed the standard for field applied fluoropolymers, which we'll have quite a bit of talking and discussion on today. And then lastly, we are a big part of AIA and their continuing education program. And if you see here on the left bottom of this intro slide here, if anyone is in the need of any credits for this particular presentation, we'll have a 1 hour to issue. If you would email me at the end of the presentation, I can add your name and particularly your AIA number into the database system, and then we can get you, make sure you get those CEUs delivered to you. So without further ado, I'm going to go ahead and get this presentation started. The title of this presentation is Curtain Wall and Facade, Architectural Metal, Restoration and Maintenance. And so the objectives of this presentation are to provide the observations of Class 1 and Class 2 anodized aluminum as they are in the field, and then as well take a look at the 3 primary finishes coming out of the factory for architectural metals, and that is the AMA 2603, 04, and 05 finish. We'll look at those standards and how those particular finishes age in the field and how to restore them. And then we'll look at methods of maintenance and repair for all of these features here. So the first thing I want to talk about here is anodized aluminum. There are essentially 2 types of anodized aluminum. If we just simplify this, there's Series 1 or Series 2, also known as Class 1 or Class 2. A Series 1 or Class 1 is primarily an exterior use, and then the Series 2 or Class 2 is an interior use. If you were to take a series 1 or series 2 and put them up next to each other, you wouldn't physically be able to tell the difference between the two. You'd have to use a tool to measure the thickness of the anodize that has been essentially installed into the aluminum. So if you don't know what anodized aluminum is, it's always great to start there. So anodized aluminum, in its simplest form of explaining it, is taking a raw piece of aluminum, dipping it in a bath of sulfuric acid with an electrical current for a specific period of time. The great history of anodized aluminum is once anodized became sort of a mainstay or began to make its way into the architectural community, there was, initially, like in the 1950s, they called it 1 hour anodizing. So they would take the piece of aluminum, they'd put it in the bath for 1 hour. That 1 hour in the bath the aluminum would grow, inherit to itself an anodized layer protecting itself, and that would come out of the vat at 2.2 mils thick. So if you were to measure the thickness of what the aluminum had grown inherent into itself, it would be 2.2 mils thick. If you take this over the decades, in the 60s, in the 70s, there was obviously a continual trend to try to operate with more profit. And so the standards started to diminish a little bit. So the 1 hour anodizing went to 45 minutes. And so then the thickness of the anodized aluminum would come out at 1.65 mils, I think, in those decades. And then if you fast forward to today, the standards have continued to lessen and lessen from where they were at in the 1950s and 60s. And so today, a typical piece of aluminum for an exterior grade goes in the vat for 17 minutes, and it comes out at 0.8 mils. So the importance of that 0.8 mils we'll show here shortly is there's a baseline or a minimum for performance. On the interior, there's much less need for the same level of thickness as the aluminum isn't exposed to the elements and the harsh conditions of rain, acid water, or UV from the sun. And so when we take a look here, yes.
Chris, I'm sorry to interrupt you, but we're not seeing the slides advance.
Okay, let me stop and go back here. I'll exit. Thank you for telling me. I'll try one more time. Are we looking at conditions and observations?
No, I see the first slide, the intro slide.
And we were doing great before we started that. Let's pause for a second. I'm gonna try this another way. Okay. Are we seeing any advance of slides now?
Yeah, we're seeing all of the slides, but yes, we're seeing it in presenter mode.
Okay, let's just see if we can change out of presenter mode real quick. We just need to exit there. Let's try one more time. Okay, how about now?
Okay, yes, we're on conditions and observations.
Okay, excellent. So going backwards very quickly, this was the slide I was trying to talk through on the class 1 and class 2s, one being the exterior and one being the interior grade. So now as I advance the slide here, what we're looking at is a cross-cut section of a piece of anodized aluminum. And if you look in the lower area of that cross-cut, you'll see that's the raw aluminum. And then what's grown into that now is the anodic cell. And that cell has grown from the aluminum based on the treatment that it had had. On the right-hand side, you'll see 0.7 mils. 0.7 mils is the minimum thickness for the anodic layer to protect the raw substrate from corrosives that could otherwise attack the natural aluminum on the exterior of a structure. This same slide that I now advanced will actually show what happens when the anodic layer is no longer 0.7 mils or above thick, And so it's no longer able to protect the aluminum. The corrosive, either UV or waterborne materials are able to attack the aluminum, which ultimately leads to pitting or corrosion of the aluminum. All metals are from minerals, and aluminum from bauxite. All of these items want to go back to their original raw form. So when they're exposed to oxygen and water, they start to break down. Just like iron would turn to red rust, aluminum turns to a white oxidation, if you will. And so that's what happens when the anodizing isn't thick enough to protect it. This is an example of a piece of clear anodized aluminum that has been breached and the environment was able to attack it. And so what sets in is these corrosion or pitting, if you want to call it that, on the actual material. And what happens is it's being eaten away at, the aluminum's being eaten at. And when you try to correct this condition, once the corrosion has already set in, you clean the surface, but the underlying root condition, the issue that was caused, is still there. And so we look at that close up and you'll see that crevice. So the topical cleaning of this material, this item, didn't actually correct the condition that was there underneath. So once this has occurred, it can't be reversed. So the key is to make sure that the aluminum, the anodized aluminum, is being maintained in a proper way so that this doesn't occur. Because at this point, you're at a point of replacement or refurbishment in the field, which is neither one is a very cost-effective solution. So what I want to show here is a very small case study of what happens, what typically happens when someone has an existing structure, they want to clean it, they want to either make it look better, or it's time for them to get things clean on the structure. So this building is in Memphis, Tennessee. It's about a 26 or 28 story building, class 1 exterior, obviously installation of a clear anodized product. And so the ownership wanted to clean the building, looked a little dirty, and so they called us in. On the left-hand side, you'll see a sample or a mock-up that was done by another company. And they said, wow, we really love this, but let's call in Stuart, the professionals first and make sure we got this right. So when we came, they showed us the area that they had done. And so we see on the right-hand side, the bottom right, is the building, the anodized before it was touched was 1.3 mils of thickness. The sample, the mock-up, was at 0.7 mils. So the effort that was taken to clean this mock-up area actually removed nearly 50% of the anodizing, or the anodic layer that was there. The detriment to that, obviously, as we had previously seen in some of these slides, is you've cleaned it and made it look really good, but you've scrubbed off so much anodizing that you've actually put the substrate itself in a very compromised position. What happens when you do this is you scrub off too much anodizing is that within a year's period, all of those corrosive materials in the environment attack the aluminum. The onset of advanced corrosion happens quickly, and then you end up with a situation where you have to replace the product or consider repainting the whole building. So the important thing here is that when you're going to clean and maintain anodized aluminum, you have to know what you're doing. You have to know what you're looking for. You have to measure the existing anodic layer, understand how much you can clean it. So you could scrub it with abrasive pads and chemicals and do way more damage even though it looks beautiful. You have to measure the existing layer, see how aggressive you can be in cleaning it so that you don't do more damage than good in the situation. So we run into this often. A lot of buildings are permanently damaged because people come in, they do a really great job representing a product, but ultimately they don't know what they're doing because they don't understand that anodizing can be permanently damaged in the field just through efforts of cleaning. If you're not familiar with these guidelines, these are excellent ones to look at when you're looking at a structure to clean it or maintain it. These are the AMA specifications for the cleaning and maintenance of architecturally finished aluminum. Those are AMA 609 and 610. If you don't have a copy of them and you'd like them, please let me know and I can get you quickly in contact with those. So the next thing we're going to look at are the 3 primary finishes. So I say that these are finishes, but they're really coatings that are coming out on architectural aluminum out of the factory. These 3 standards or these guidelines, I should say, the standards are written by the AMA. AMA is the previous group that wrote these. Now it is known as FGIA, which is the Fenestration and Glazing Industry Alliance. So AMA teamed up with a Canadian organization just as their own, and they created this sort of this international alliance here. And so what we'll be seeing soon is these AMA, which we've been referring to them for 30 plus years now, are going to be shortly seen as FGIA standards. So I want to just bring that to everyone's attention. So the AMA, or the FGIA 2603, is the lowest tier of the three in the family. We refer to as typically as a powder coat. So there is a optional pre-treat to the aluminum, no primer, and then 2.2 mils of dry film thickness on the powder, which is typically a polyester that's applied to the finish, applied to the substrate, and then baked in the oven. When we observe what a 2603 looks like in the field after a number of years, it's typically a telltale sign if you're dealing with a powder coat or a 2603 is if you rub the surface and the pigment comes off in your hand. That's a telltale sign. So the polyesters don't have excellent UV resistance for chalk and fade, so they break down at a more rapid rate than some of the other coatings that are put in these families. So typical service life of a 2603 is 7 to 10 years in the field, ultimately depending on what sort of geographical region it's installed in, so how much sun exposure it really has. And then when we're asked to replicate the service life of a 2603 in the field, so it's saying, hey, we'd like to come out or we'd like to field paint something and we're only looking for 7 to 10 years of service life in it, normally we'd use what's called a direct to metal product or a DTM. So you would wash the surface, little to no surface preparation, you put this DTM product on here, and you've bought yourself a little bit of service life in that same range of what a 2603 would be. The next finish in these three is a 2604. So if we want to look at these as good, better, best, this would be the better of the three standards that are out there for these finishes. The 2604 really comes in two different formats, is probably the best way to say it. So you can do it in a wet format, which is again a voluntary pre-treat. It'll have 0.35 mils of primer and then 0.85 mils of the top coat, for a total of 1.2 mils. And this would just be for a monochromatic, no metallic, no mica on that. So that would be the standard for that product coming out. And there's also a powder, which is similar to the 2603, except what they have is a super polyester. And the super polyester is a polyester but bolstered up to have better performance standards behind it than the typical polyester would. So they beefed up the coating so that you can get better gloss retention, better chalk and fade results to fight UV attack that occurs. The typical service life when we're looking at the 2604s can be anywhere between 10 and 15 years, again, depending geographically on where they're established or installed. This is a look of an aged 2604. It doesn't have the same chalking and pigmentation if you were to touch it, but it really starts to get mottled. So the binders start to break down in the coating system. They've fought off the UV attack for as long as they could, and they just start to look like this. And it'll also happen exponentially. After a number of years of trying to fight off that UV attack, it'll start to take a downturn, and ultimately you're at a point of needing to fix it just purely based on the aesthetics of how it's looking at the time. And then when we look at a 2604 and we're asked to replicate that service life of 10 to 15 years on that coating system, we'll typically go with what we call like an industrial urethane or a polyurethane system. We'll put an epoxy primer on to restore the system, and then put the polyurethane on top, which has excellent UV resistance and great gloss retention on this. So this is just an example of what that would look like if we were trying to get, again, that service life reinstilled on it. And then what we like to call the Cadillac of coatings, this is the best out of the system. An AMA 2605 or now an FGIA 2605. This now has two formats. Typically it's been one just in the wet. And this is a voluntary pre-treat, 0.35 mils of primer, 0.85 mils of top coat. The top coat in the 2605 is exclusively a fluoropolymer. And if you're not familiar with fluoropolymer, you may have heard of the word Kynar. Kynar is a brand of resin that goes into a fluoropolymer. There's other brands like Kynar that go into these resins. The best way that we use to describe what a fluoropolymer is imagine Teflon, which most of us are familiar with. You pulverize Teflon, you put it into a can of paint. Those type of characteristics that Teflon have is what a fluoropolymer gives. It has great scratch abrasion resistance, chemical resistance, great UV, gloss retention, chalk, all those things I talked about earlier. That's what a fluoropolymer is. And that's why it's the Cadillac of coatings, or the best coating system in the world when it comes to architectural finishes. The newer format in a 2605 now is a powder. And so they advanced the technology. They were able to take fluoropolymer, make it into a powder format, and then have that installed onto these substrates in the baked system that are creating these new lower dry film thicknesses, but with the standards, meeting the standards and requirements of the performance characteristics of the previous wet system that existed there. Typical service life on a 2605 is 20 to 30 years plus. We've seen structures that look absolutely fantastic 30, 40 years after the install coming out of the factory. Normally what happens in these situations is the sealants and gaskets and all the things surrounding these coating systems, their service life expires before the coating system even does. And so what happens is the sealants start to leach onto the panels or the substrates, and they're attracting dirt and grime, and they're starting to leach onto the panels. And so normally you're looking to restore the panels only because of the look of them, even though they're still performing fantastic. The surrounding items have now broken down and caused issues not inherent to the coating system itself. And so then we look at, how do we replicate a 2605 service life in the field? How do we apply a coating that's going to last that long? And it exists. There are field applied fluoropolymers that provide a 20 to 30 year service life when installed in the field the right way. So this is an example of that same building with a brand new coating system being installed that will provide them, extended service life for several decades here. So the next section I want to share with you is coating failure. These are the primary coating failures that we observe in the field at Stuart Dean when we're asked to inspect buildings, take a look at what's going on, what's happening with our structure. And so the first one is what we call adhesion failure. Just because you paint it doesn't mean it's going to stick. It happens so often that field applied coatings are installed by folks that don't understand the importance of or understand how critical it is to properly provide surface preparation to a substrate the right way. When that's not done correctly, paint it, it looks great, the check clears the bank, you get a full thermal cycle in that region, and then the paint falls off the building. It happens all the time. Standards have to be done the right way. These coatings need to be installed the proper way as well. So we're often fixing these issues after the fact. The other condition we look at is actually looking at a condition and saying, if you have a condition that exists, you can't just cover it up. So here we've got some corrosion that's set in on a building, a coastal installation, and the building for years just kept painting over this condition. And what happened is it just continued to fester. So the corrosion's underneath the coatings, and it's just building and building like a cancer, and it's getting worse and worse. It's eating away at the aluminum. You're covering up the problem. You have to remediate the issue underneath the underlying area. You can't just cover it up. Like if you were to try to paint a piece of steel that has rust underneath it, you're just exacerbating the issue because you're covering it up and giving it the opportunity to make itself worse. And so when we investigated the building, we broke open some of the coatings that were there. The aluminum had been eaten away so much that the paint seemed like it was thicker than the aluminum on the building. And they asked us if we could repair it. We said, we cannot remediate this. The issue is far advanced from being able to be fixed. We recommended the entire curtain wall on the structure be replaced because the condition had been hidden for so long. The The other condition we see in the field is we observe coating breakdown. And what happens in coating breakdown starts with understanding how the coatings themselves work. So primers are installed on raw substrates to promote adhesion and retard corrosion. All primers are photochemically reactive, meaning if they're left alone, uncovered to the sun, they'll actually blush and bloom, and they'll break down and eventually wash off the surface. Top coats are installed on top of primer systems to act as sunglasses. So they're there to protect from the UV attack. They can fight off against that. When the top coat is not thick enough to protect the primer, meaning UV can pass through it because the thickness wasn't enough, that's what you get when you see coating breakdown. So in this case, in this photo, hopefully you can see it, second row from the bottom, that panel, you can actually see some green in there. The green is the primer that was broken down by the UV sun. On this next slide, the left picture, you'll actually see the raw substrate where the coating had been broken down, blushed, bloomed, and the water and rain washed it away. The photo on the right is the same building or same structure with a column that was under a canopy or a covered area, little to no UV exposure, same panel system that came out of the factory, but the coating breakdown didn't occur because you didn't have the UV attack like you had in the picture on the left-hand side. So we'll see this as a factory defect. We'll also see it as a field installation defect. If someone paints a building, they don't put the proper thicknesses in, you can have that coating breakdown happen. And then another condition, which is primarily revolved around a marine or a coastal environment, as we'd say it, are the attacks of salts or chlorides. This condition is known as substrate corrosion, also called filiform corrosion. And what happens is the salts, the chlorides, two different words for the same thing, will find weaknesses in the coating system, either at an exposed edge or just some pinhole in the paint, will attack the aluminum. Salts like aluminum, they'll break them down. They'll travel underneath the coating system and continue to eat away and fester at the aluminum, and then find ways to ultimately lift, as you can see in this photograph, and to laminate the coating system, exposes the raw substrate, and now the raw substrate is going to continue to be exposed to that marine environment, and things will continue to exacerbate and get worse. What we have here is a close-up of what that is. So you'll see that upper left photo here, we actually have right in the middle of a sill. So not where there was a cut edge, but the corrosion actually traveled underneath the coating system, found itself in the middle of the sill, and eventually bubbled up and then delaminated in that area. And so that's what that looks like up close. And then this next photo is just a representation of that condition, the corrosion or the filiform corrosion, completely remediated and then fixed, and a new coating system installed in the field to renew the service life of that structure. Just a summary of some of the items we just covered and what those coating breakdowns are. Next, we just want to share with you a few of the primary methods of surface preparation that go into the installation of field applied coatings. So the first one is dry ice blasting. Dry ice blasting is a really environmentally conscious way of attempting to provide surface preparation to a surface. It is very tedious, pretty slow, but when the right project or right conditions call for it, it's a pretty cool methodology of doing things to get the surface ready for the installation of a coating. The other unique surface preparation that I would say 10 years ago, I'd tell you would be so costly and so expensive that you'd have to get a Brinks truck, back it up and empty it out in order to make this happen. Today, primarily due to the military and the armed forces, they have taken laser stripping and they've advanced the technology to such a way to be able to maintain some of their vehicles and such, that now this is finding its way into the commercial world. So we expect this type of surface preparation to continue to evolve, be more cost effective, and ourselves using it on mid to high rise buildings to provide surface prep. And so what the laser stripping does is it will take a laser, remove the coating, and at the same time provide the surface preparation that you need without leaving behind a mess or residue or any of the things that normal surface preparation will do. And it's done very quickly when you have the right equipment. And then this process is a very interesting one. It's just like media blasting, but it's called sponge blasting. And the unique characteristic of sponge blasting is you can remove a coating if you need to, and then provide the exact profile of the surface prep that you want out of your blast. So if I wanted a 1.5 mil profile during my blasting process on the substrate, I could strip the coating and provide that surface prep at the same time. So essentially doing 2 steps of a process that can be very timely in 1 step. So that's just a pretty cool one that we like. And then chemical stripping, we're getting to the point where this is essentially banned and outlawed based on how ugly the chemicals are. That they're just nasty things that really don't meet any of the regulations and requirements out there anymore. And so one of the processes that has taken over for chemical stripping is a process called peel away. And what happens with peel away is you take a environmentally friendly, regulated, that meets the regulations gel, you put the gel on the surface, you cover it, and then you let it set up for a period of time. It could be 5 hours, could be 12, could be 24, 48, depending on how long that product or that gel needs to sit in the surface and do its work. And then what you do is you take all that covering away, remove the coating with it, and then you can dispose of it, and then you'll have full removal of that coating. So this is a really cool way to get this job done when it's necessary. And probably one of the most important things that we try to educate the architectural community on is sealants and their relationships to coatings. And first thing is, if you install new sealant on top of a coating that has bad integrity or little integrity, meaning it doesn't have good adhesion to the substrate, the new sealant is only as good as the service life of the bad coating. So if the coating's peeling off and delaminating, it's only going to last 1 or 2 years, that sealant you installed that should have a service life of 15 or 20 years is only worth 1 or 2 years. So you can't install sealant on top of something that is old or at the end of its service life and needed to be renewed. The other thing that is very common in the world of painting is painting up to or over silicone sealants or gaskets. You can't do it. Silicone will not take paints or coatings. It will delaminate, it will peel no matter what. It always happens. The proper way to do work when you're around any sort of gaskets or sealants is to remove the gaskets and sealants, do all of the field coating installation, and then put brand new gaskets or sealants in. And these next couple of slides will represent just a few details of what that looks like. What we see here is like a metal-to-metal joint location, and there's the removal of the existing sealant, the installation of the new coating system that terminates over the edges, and then the install of either a new urethane or silicone, typically silicone when you're dealing in a metal installation. And then this detail here would be representative of a piece of glass and a mullion, like at a curtain wall system. So you either have an existing wet seal of silicone at the metal of the glass, or you have a gasket in that installation. You cut back the flange or the exposed area of the gasket or sealant. And then in this next picture here, this next depiction, you'll see in blue, the new HPC high performance coating is installed, and then the new silicone sealant or gasket is installed on top of that. So the coating is now terminating underneath new weatherproofing. So you give a brand new service life to the coating, and you've got a watertight sealant or gasket on top of a brand new coating system. And what we have here is just a couple of photographs representing that. On the left-hand side, you'll see the silver. That's the metal-to-metal new installation done the right way. And then on the right-hand side, you'll see the metal-to-glass installation done the right way. So new coating system installed, and then that new, call it wet bead of silicone put in place there. So 1 second here. I'm sure as you can tell so far that quality assurance is such a key component to the restoration and maintenance in the field. And most of the quality assurance standards and protocols that are put together by Stuart Dean are really evolved around NACE, the National Association of Corrosion Engineers, as well as the Society of Protective Coatings. And so over the years of Stuart Dean in its lifespan of providing service to the industry, which is now 87 years, we saw a lot of imitation, a lot of people just learning from the person that trained them. And the reality was they didn't really understand the science of what needed to happen. They just followed instruction to it. And so once we became a part of these critical societies and these organizations to understand the science behind it, we developed a training center in Cleveland, Ohio. And we took that training center, which is the 10,000 square foot facility, and we brought in the leaders from the industry, the coating manufacturers, the fabricators of curtain wall systems, the installers, all the people that were making product within the fenestration industry. We brought them into our center. We continue to bring them into our center for the last 15 years now. And we provide the hands-on training necessary to work with the products in the shop environment that can ultimately then be translated into the field. And alongside of doing that, some of the most critical things in the field restoration is understanding what it is you can work within. You're in an exterior environment, non-controlled, and we have to teach and train people to measure for air temperature, surface temperature, relative humidity, the dew point, the delta of those, to understand when and if you can even apply these coatings in the field to to meet the requirements and the standards of the manufacturers. Also have to understand the inker profile. We talked about surface preparation earlier and how critical that is, and making sure that we're measuring that the proper surface prep is being done so that the coatings being installed have a bite or teeth. They have a place to anchor themselves into and ultimately have the proper adhesion to the substrates. And then measuring for dry film thickness. We talked a lot earlier about dry film thicknesses, both in anodizing and in the 3 primary finishes from factory. We have to measure for those so they're installed in the field at the right requirements by the manufacturers. And then also testing for nitrates and sulfides using the proper equipment. And then more importantly, when we looked at corrosion in salt environments, and that's testing for chlorides. Anytime you're near 1 mile near a body of salt water, there will be chlorides on the surface. If chlorides aren't properly removed from the surface, they're trapped underneath coating systems, and then that issue we've seen before will continue to fester itself underneath the new system. And then we always put up mock-ups in these areas whenever we're looking at new structures for installation. We put it up, we make it look beautiful, and then we destroy it. So we're testing for adhesion. This particular methodology is called the dolly pull test. We glue dollies to the new coating system, and then we use pressure to pull these dollies to ensure they're within the right standards and specifications of that. Just an example of a training class that's come through that particular training center. And then a quick take a look at some of the certifications that we've offered through those manufacturers and industry partners that we spoke on. And then field repairs. Not looking at aged systems, as we've pretty much seen so far, as aged coatings in the field, how do we repair them? The other big part of this industry that we're in is newly installed finishes. Brand new, going into new installations on new builds, if you will. There is so much damage that occurs to the interior of new window systems, curtain wall systems, however you want to call them, that happens by trades, happens by installation, happens by accident, or even happens because there was a manufacturing defect in the coating system. And so Stuart Dean, having 27 locations across the United States, is a big component of the architecture community in basically fixing these finishes in the field so that the warranty coming out of the factory from the manufacturers are not affected. And then also, most critical, making sure that the color matches and the work is done in the proper way so that all of these things can be looked at and be punched and approved and can move on so everyone can continue on with what they're doing. So these are just examples of work items that we see. Typically, you have protection on them. Even the protection doesn't do its job sometimes. You'll have areas such as this where the coating will be, disadhered from the substrate. And then this is the more common thing: dents, scratches, trade damage that occurs from other people coming through these areas, unintentionally damaging brand new product, and what that looks like. And so now I want to share with you some examples of some of these projects in the field. You'll see the conditions that we were challenged with, and then some of the solutions and how they came about. This is the Equitable Building, downtown Atlanta, 100 Peachtree. It's a Class 1 anodized aluminum on the exterior of this building. I'm going to say when we restored this building, the anodizing was probably about 30 years old. You'll see on the left-hand side a breakdown and the onset of oxidation of that anodized product. On the left-hand side, we had the ability to clean the anodizing while measuring the thickness and then apply a protective clear coat to the structure. So what that did is it stopped the UV attack and the continual breakdown of the oxidizing or the corrosion process that was occurring to the anodized. So we clean it, we arrest and suspend the corrosion that's occurring, and then we're able to protect that with a clear coat rather than have to paint the structure. And so this is a very similar structure, Class 1 exterior Duranodic anodized aluminum. Duranodic is just a term for a bronze on the exterior for an anodized structure. On the right-hand side, you'll see what we would call significant or severe breakdown of the anodizing. We actually recommended that the owner consider repainting all the panels because it was so significant. It wasn't in the budget. On the left-hand side, you'll see that we were able to clean it, put that protective clear coat on it, and improve the aesthetics. But more importantly, we were able to advance the service life without having to remove or replace the exterior skin on that structure. And then this building in San Francisco, 425 Market, is a Class 1 clear anodized aluminum, so like a silver anodized. This, for the last 3 decades, every 10 years, has been restored with a clean and clear coat process. So just making sure this building is making sure that they are getting the most service life they can out of that exterior product by maintaining it, which is really the right way to go about that. This whole city block in Brooklyn, New York, is 395 Flatbush. It's the Verizon headquarters for training. This was a Class 1 anodized aluminum Duranodic product that was so significantly damaged, it was about 45 years old, that it actually had to be repainted. All of the sealants were removed on the building. A new fluoropolymer system was installed on the outside, and then all new sealants were reinstalled, probably extending the service life of this structure another 30 years without having to reskin the building. And then this one's really unique to the portfolio. We love talking about this one. This is Fox Plaza. It's also known as the Nakatomi Tower from Die Hard. Those of you who might remember the building or the movie. The exterior of this building was a 2604. Only after about 15 years, significant breakdown started to occur on the curtain wall of the system. And so over a 2-year period, we multi-phased it, scaffolded the whole building, removed all the sealants and gaskets, and installed a new fluoropolymer coating system to that structure there. Upper left-hand corner on this large campus is the San Diego Tech Center. You can really see that modeling and breakdown. If you remember back to the 2604 section of this presentation, I said that what you start to see when you see an aged 2604 is this modeling look. So if you rubbed your hand on this, you wouldn't get pigment, but you really start to see this thing, broken down. The binders are not holding up anymore. Significant sun exposure there in San Diego, obviously. I think this was 10 buildings on this campus, fully restored using a fluoropolymer system. And then a whole city block in New York, very close to Stuart Dean's headquarters, right near Times Square. This was a 16 swing stage project done in a 4-month duration over a summer in 2014. All of the sealants and gaskets removed and replaced in this building, along with the installation of new fluoropolymer system. And then a really unique one, the original IBM campus in Silicon Valley. All the courtyards have these very exotic colors. And so the buildings were actually referred to by the colors of the courtyard. That's how people designed their meetings or knew where to go. And so the exotic colors actually started to break down, and some of them were becoming difficult to know what colors they were. So we were able to find the original PPG factory colors for these panel systems, and then we're able to repaint all those courtyards in the proper colors. The exterior of all those buildings was a class 1 clear anodized aluminum, and we were able to clean and clear coat all of those, giving a whole new service life to the entire campus there at this Silicon Valley area. And the next thing I want to share with you is some new technology. So over the past 30 years, the standard has been solvent-borne coatings that are installed in the field. They're stinky, they're nasty, and in addition to that, they disrupt operations in buildings. They continue to cause nuisance odors for other trades, for occupants of the buildings, and more importantly, the regulations that are being put in place now for VOCs are becoming so stringent that most of the coatings that have been used over the past 30 years are no longer able to be or won't be able to be used and installed in areas of the country, most areas of the country, in the near future. So what we've been able to do or find is water-based solution for these fluoropolymers now. And so I want to share with you a very short video of this new technology, what it is, and then share a few examples of a couple projects that have recently been done utilizing this new technology. And so the reason I share that with you is that is probably the biggest advancement in the coatings industry for field applied coatings in the last 30 years. And we really see this as the future of occupied structures for restoration. And it's really a key element of the approach that we think we need to take in order to restore a lot of the architecture out there instead of replacing it. So this particular example is one of the first structures that was done, metal structures that was done in this product system, 610 Newport Center Drive in Newport Beach, California. Fully occupied structure, primarily law firms and attorneys were in this structure, not a single complaint or shutdown of operations, which for us is a phenomenal feat because normally odors are a major issue in the installation during these projects. And so here's some of the work in progress And then a very high-end residence in Albany, Bahamas, also restored in that product system. Recently, a Regeneron campus in Sleepy Hollow, very old, very aged 2604 system was reinvigorated with this particular product. The CNN building in Hollywood was also redone. And then this one's important to know. So this was a fully occupied or fully operating hotel, if you will. Didn't lose a single room during the process of this entire restoration of the campus. Both all the metal on the windows, balconies, as well as the brick facade was restored using that product system, again, with no disruption to the operations. So that's what I have for you today. I hope it was informative. Want to open it up to any questions anyone may have. And then here's my contact info again for any AIA or any information that you may have or questions. Please feel free to reach out.
Great, thank you for a wonderful presentation, Chris. That was really, really informative. A reminder, if you have a question, type your question in the question box, and I can read them to Chris and let him know that he has some questions. So we do have one. Can you give a rough order of magnitude of the cost difference between replacing and refinishing a damaged facade, i.e. extending the service life by another 15 to 20 years?
Yeah, it's a great question. We get it asked all the time, and it's very difficult. It's project by project or building by building, but I would say, a ROM on something like that is probably 10 to 20x the cost to replace. The other factor, obviously, in consideration of that is the disruption to operation and the tenants that exist within a structure. And that's a whole thing you can't even calculate in that process. But I think 10 to 20 is probably a good ballpark.
Okay, thanks. Another question we have, track record of FEVE versus PVDF coatings.
Oh man, you really, that goes to the chemists. But there is great supportive data from the fence, which the fence is, taking these technologies, putting them out in a Florida farm, typically panel farm. They put the colors out there. They let them stand up the test of time to the extreme sun of a Florida environment. And then over that 10, 15, 20-year period, they'll see the results of them. I couldn't speak knowledgeably enough on the FEV versus PVDF performance. I'm familiar with both of the technologies, but I wouldn't be able to say, which one could perform better than the other or has based on that.
Okay. Does anybody have any other questions? I don't see any others so far. Let me see if there's anything else. Oh, here we go. What is the permissibility of the coating? Oh, permeability. Sorry, I read that wrong. What is the permeability of the coating? My concern specifically is placing this product on brick and mortar.
Yep, that's a great one. So it's much different than an elastomeric product, which an elastomeric is designed and created to essentially not allow permeability, right? And so you put that on typically masonry substrates and stone so that it sort of stops it from having exposure to it. This particular product, the Never Fade one, which I represented, which isn't what I'm representing here, not a product, but just the products in the field and showing the new technology. But that product, the Never Fade product, was originally designed for stone application, and then it was taken and advanced into a metal technology. So it is designed to be put on stone and does have great permeability. The Never Fade website has a lot of great information on the product data for that product, as well as some of the testing that's been done on it.
Okay. I'm assuming this is related to that product. They're asking, what is the longevity of the product?
Yep, 15-year warranty for labor and materials. And I mean, longevity of most fluoropolymers is going to be 20 to 30 years on a field install. Most of the weathering and testing has been done both on the Florida farm as well as what they would call accelerated testing. Fortunately, Arkema, which is the largest resin manufacturer in the world, who created the original Kynar, they created the Kynar Aquatech, which is the resin within that Never Fade product, many years ago. So I want to say they've had product on the test fence for over 20 years now, prior to the Never Fade formulation being created. So there's some really great historical information and data available. In fact, we've been involved with some projects where that's been a requirement to be able to show some of the weathering characteristics from actual, on testing, if you will. And so that's available as well.
Okay. Are there SMP products that can meet the 2605 level of performance?
I'm not familiar with SMP. If you could take it a little further, maybe I could help.
Yeah, I'll give them a chance to
No problem. Sorry about that.
expand on that.
I'm knowledgeable in a very finite area, and I think you guys might know what that is now.
Silicone modified polyester.
Oh, does the silicone? No, it to my knowledge, thank you for that. I didn't know what that is. I didn't recognize SMP for that. To my knowledge, that does not meet the 2605 the standards that are there. I believe SMPs do meet the 2604, and they may even fall into the categories I was kind of referring it to as a super polyester, which is not the official technical term for it, but I'm pretty sure that that's what that falls into.
Okay, are there any other questions? It looks like, I think everybody is, oh wait. Oh, what is the best product or solution for cleaning water spots on anodize?
That's a tough one. I would say, to start with something, this is very simple, easy to get to, is get some barkeeper's friend, typical hardware store pickup, and use a soft cloth to try to remove that. But just keep in mind, if you scrub hard, you can ruin the anodizing. So it's good to dilute the product in water and then use that to try to clean it up. The reason I say that is there's a little bit of oxalic acid in barkeeper's friend, and the oxalic acid usually helps to get rid of whitening or water spots on it. But just be very careful with the abrasive that's inside of the barkeeper's friend.
Okay, and what about grease marks?
Try the same thing. Honestly, that's one of the go-tos for easy fixes on anodized.
Okay.
Nancy, I want to put your slide up. Make sure we have time for some of the resources for AEC.
Yeah. Okay. Well, thank you so much for all those questions, everybody, and Chris for a very informative and enlightening presentation. Just so let everybody know, this presentation is being recorded, and a link to the recorded webinar will be sent following the end of this presentation. I think the email will go out tomorrow, so look for that tomorrow. And AEC has a number of resources that might be useful, which are available on our website. Visit aec.org to download white papers, the aluminum extrusion EPDs, corresponding life cycle analysis, and an extruder that might fit your needs. You will also find publications that may prove useful, like the latest issue of the AEC Buyer's Guide and the AEC Aluminum Extrusion Manual. The extrusion manual contains a wealth of information on aluminum extrusion process, design, applications, finishing, sustainability, and much more. And you can view the extrusion manual at aecmanual.org. In addition, AEC recently launched a new section on our website devoted to aluminum extrusions in educational settings. The interactive pages provide valuable information on how aluminum extrusions facilitate educational environments. Explore the various extruded aluminum applications for this type of design by clicking on specific fenestration solutions like skylights and overhead glazing or high performance windows, and learn how extrusions contribute to such goals as student learning and well-being, security and safety, environmental stewardship, and much more. This is the first module focused on building and construction applications, with more to come for other architectural focuses in the future. So check this one out at aec.org/schools. Again, thank you for joining us today, and thank you, Chris, for a great presentation. We hope you enjoyed the webinar today and have a great rest of your day.
Thank you, everyone.